Okay, so today we're going to talk about transcription in both prokaryotes and eukaryotes and the differences. And we're also going to talk a little bit about translation, how transcription leads us to then translation. Okay, so first let's start off with prokaryotes. So transcription in prokaryotes are going to be it's going to be a little less dense than, say, eukaryotes. In prokaryotes, there's only one RNA polymerase, and that RNA polymerase can be thought of that's made up by two separate entities, or has two parts to it. One part, the A part, would be the core polymerase. Now that core polymerase is responsible to synthesize RNA using a DNA template. However, the one thing, and the reason why it needs a hollow enzyme, is because it cannot initiate transcription. Again, that's where the hollow enzyme comes in. It can initiate the transcription assembly accurately. RNA core polymerase can initiate transcription, but it doesn't do so accurately, so that's why it needs a hollow enzyme. After that, each prokaryotes have promoters, and promoters are the binding site and also tells a polymerase where to start and the direction. So the 5 to 3 direction, that's going to be caused by the promoter. Prokaryotes also have a terminator, much like eukaryotes, and the terminator is basically a signal to stop transcription. And transcription usually starts with ATP in prokaryotes or GTP, and it happens in a 5 to 3 direction. And the process of leaving polymerase, basically breaking with the promoter and then going down to get more, to transcribe more information, more RNA, is called escape. And each time the polymerase does that, it modifies itself, or it breaks off a little piece of itself, and each time it goes down, the bond is getting weaker and weaker. The transcription bubble is the part that's actually being transcribed. So all the proteins that are, that are transcribing the RNA is called the transcription bubble. Now let's move to eukaryotes. In eukaryotes, it's a little trickier. Eukaryotes have 3 RNA polymerase, and they have 3 distinct promoters. Now, the RNA polymerase that we see being used the most, or is the most important for today, is RNA polymerase 2, and also the promoter that goes with that as well, promoter 2. So they have transcription factors to aid in recognition, unlike prokaryotes. And these factors interact with RNA polymerase 2 to form an initiation complex. Now, the termination act is defined just like in prokaryotes. However, in eukaryotes, it's a little trickier. And we'll go into that later. Also, unlike prokaryotes and eukaryotes, the end of mRNA is informed by RNA polymerase 2. RNA is synthesized by RNA polymerase 2 in primary transcript, and the final process form is mature RNA, or mRNA. After this, mature mRNA. Another thing that's different from eukaryotes to prokaryotes is the tail, and, well, basically the ends. So in eukaryotes form a 5 cap to protect them from degradation. As well, on the other side, they also form a 3 polyadenine tail. Now this is made up of about 100 to 200 adenines, or A's at the end, and they play a role in stabilizing this, and it prevents from degradation, just like the 5 cap, and that makes it very, very different from the prokaryotes. So shortly after this transcription, the RNA is then shuffled, the nuclear RNA is then shuffled over here in translation, and basically how this works is a ribosome is made out of 2 pieces, the large subunit, and the small subunit. The small subunit is mostly for encoding. The large subunit is actually for processing. So the nuclear RNA is going to come in, and it's going to basically move much like it did in transcription. It's going to be shuffled in, and it's going to go into the first site, which is the A site. Whatever binds to it is going to be left in the P site, and then the part that isn't going to be used is going to go to the E site for exit or extraction. And that's basically how transcription and translation works in prokaryotes and eukaryotes. Thank you.